Welcome all to the first session of Intermediate and Advanced Python. Today we'll be looking into map function, filter function, lambda expression, arguments and keyword arguments. Now a map function, as the name suggests, maps one function to an iterable. So an iterable is basically a list, a tuple or a set. Now a map function takes two arguments, the first being a function and the second being an iterable. Let's look at how this actually works. So as I've said earlier, we need a function. So we are going to define a function. Let's define a function named 10x and let it take an argument named num, stands for number, and let's just assign a variable x, which is basically the number multiplied by 10, and let's return that. Now let's check whether the function works. So what that function basically does is that whatever number you feed, you get 10 multiplied with it. Yeah, it works. So 10x into 10x of 10 is 100. Now let's create a list, an iterable, here being the list. So let's create num list 1. Let's just say there's num list 1. 1 2 2 2 3 3 4 5 6 7 7 8 9. Okay, that looks good enough. Now let's map it. So what you do is map. I want to map the function which is 10x to the num list 1. Now let's look at what the output is. You can see that you are not getting a particular output. You are getting, what it basically says is that you have a map function which gets stored in a particular memory location. Now this is because we haven't actually defined what kind of output we want. A map function can produce a list, a tuple or a set, which means that you have to explicitly specify what is the output that you want, and you do that by typecasting this. So since I want a list, I'm going to typecast this as a list, and now you can see that the number list, you have actually mapped the function 10x to every digit in that numbers list. Now this needn't be a list, you can very easily replace it with a tuple, and you get a tuple, and it can even be a set. Now we know that a set only produces unique values, so although there is repetition of 2, 3 and 7, the output will not have any repetitions. So this is what basically a map function does. Now you have to know that there is an important point to remember. Now the function passed as the function that is passed is 10x, right? But it is passed as an argument, because if we call the function as a function itself, it would require providing positional arguments. What do you mean by that? I'll just show. If instead of 10x, if I do this and run it, it will give you an error saying that 10x is missing one required positional argument number. So we don't do that, and that is because the map function is the one that takes the function and feeds every value from that iterable into that function. So what map function does is that it takes the function 10x and first feeds 1 and produces an output. Then to the same function 10x it feeds 2, produces an output, and so on. And that is why we are not actually giving the parenthesis for the function. Well, let's run this. Now if you look at the documentation of map function, you can see that there is a sentence known as stops when the shortest iterable is exhausted. Now what do you mean by that? Now it simply means that a function, as we have defined here, can have more than one argument. So let's define a different function. Let's add few more cells to this. I'm defining a new function. Let's say add. Okay, so define add and I'm taking two numbers, let's say num1 and num2, and I'm returning, let's say num1 plus num2. Now let's check this. So add 3 comma 4, you get 7. Now if you map this function, we need two lists, right? One for the num1 and another for num2. So let's create another list. Let's say num list 2, and let's name it 10, 20, 30, something like that. And now let's map again. So map, let's take the function was add, right? Add, then num list 1 comma num list 2, and again we need to typecast this. So let's produce another list. You can see that you are only getting 3 output. And now why is that? Because your shortest iterable is this, so it gets exhausted. That's what it's meant by. Let's look at the documentation again. It says stops when the shortest iterable is exhausted, and since our shortest iterable has only 3 elements, it stops with the 3 elements. So what it did was that 10 plus 1, that is 11, then 20 plus 2 got 22, 30 plus 2 got 32, and with that the number list 2 got exhausted, and with that the map function stopped. So that's all about map function. Now let's look at the filter function. Okay, exactly the same way the filter function works. The only difference is that here instead of mapping, we're actually filtering it out. We're filtering the output that we need. Now let's say that we have a number list like this. Num list 3 is equal to, let's just 0 0 0 1 0 0 0 2 0 0 4 5 6 0 8 9. Let's create a num list like this, and I want an output where I only want the numbers greater than 0, and which means I want to remove all the zeros from the list. How do you do that? You can use the filter function, filter, and let's just look at the documentation again. The inputs are function or none and an iterable, and if the function is none, returns the items that are true. So that is basically what a filter function does. So it returns an iterator yielding those items of iterable for which the function item is true. So which means that if I write none here and I put num list 3, we know that in terms of Boolean, any number other than 0 is taken as positive or true, and 0 is taken as false. So it should return only those values for which the Boolean is true. Let's typecast this. Why typecasting? Because it's similar to map function. It produces a filter object. So let's typecast this to a list, and you'll see that it will only return the numbers which are greater than 0. Now we can do something similar. We can actually filter this out. Let's say I want only the numbers that are greater than 5, so how do you do that? For this we need to define a function. Let's define greater 5. Okay, greater 5, and it takes a number and it returns num greater than 5. Okay, now let's try it again. So filter, now here I am going to give greater 5, and let's give num list 3. I need to typecast it again. Let's typecast it to tuple for the time being. You can see that it only gives 6, 8 and 9. So this is, now you can change this. Okay, if you want only the numbers between 5 and 9 excluding 9, so you can add and let's say num less than 9. Okay, wait, num greater than 5. Okay, num greater than 5 and num less than 9. But as you can see, just for a function, just for using a filter function, you have to actually define a function here. Similarly, here also you need to define a function like add, define a function like 10x. Now that is kind of an extra work, because we just want to filter it out or rather map it, and to define a function just for that is kind of an overwork, and that is where lambda expressions come. Now lambda expressions can be slightly tricky to understand initially, so one of the best methods that I've found is to actually use an ordinary function which can be modified into a lambda function. Now what do you mean by that? Let's take this function. Let's paste this here. Now I'm going to convert this function into a lambda expression. Now how do you do that? The first step is that we remove the return, and we remove the assigning of variable and we directly write return here. Now let's just make sure that this works. So let's write 10x of 5. Yeah, this works. Now what I'm going to do is I'm going to remove this. I'm going to directly assign return num x. Let's just make sure that still works. So I'm going to give a different number. Yeah, this still works. Now next step is that I can assign the whole thing in a single line. What I'm going to do is I'm going to bring it here. I'm going to assign this to a single line, and let's just test whether this works or not. Yeah, this works. Now we know that anything after the colon is basically the return function, right? Anything after colon is actually what we want as a return. So we needn't actually mention the return. Moreover, a lambda expression is basically called as an anonymous function. And since it's an anonymous function, we needn't actually define a name for it. And since we are not naming, the arguments needn't be inside the parenthesis. So what it basically means is that I'm going to remove this, and instead of that I'm going to write lambda, and I'm going to go over like this, and let's just assign this to 10x. Okay, let's just test whether this works. You can see that it still works, but if you are assigning like this, the basic purpose is lost. So instead of that, what we are going to do is we are going to use lambda expression in conjunction with the map and filter function. What do you mean by that? Now if I want to say map a function of say cube to a list of numbers, what I'm going to do is what I'll write map, then inside that what I'm going to do is write lambda x colon x star star 3 comma, let's take the first list as num list 2. Let's take 2 and let's typecast this to a list. See, so what this basically did was that it simply took a number and took a cube of it. Now we can do exactly the same thing here. Here we did for add, we can do the same thing here. How do you do that? We can take, let's take map, and I'm going to take the lambda function, lambda, and we need two arguments. Let's call those arguments as x and y. And what do you want as a return? We want return as x plus y, comma, let's take num list 2 again, num list 1 comma num list 2. Let's typecast that to a tuple this time, and you will see that you are getting the same answer as you got here. See, the only difference is that I've typecasted it to tuple instead of a list. 11, 22 and 32. Also got 11, 22 and 32. Now this also works for filter function also. Here we did a filter function of returning number 5, returning, let's say, between numbers between 5 and 9. We can do that as a lambda function also. So what we'll do is, let's take write filter and lambda, I take x colon, let's first take every number greater than 5, x greater than 5, x greater than 5, comma, let's take num list 3. And let's typecast that to a list. Got 6, 8 and 9. And if you want, again in between 5 and 9, just write it here, x less than 9, can get 6 and 8. So that's all about lambda expression. So lambda expression is kind of tricky. You need a basic practice of how to write a lambda expression. So one of the best ways is that if you have any doubt of how to construct a lambda function, you just start with the basic definition and then you correct it and build it over it until you get a lambda expression. I'll just show one more demonstration of how to do that. Let's create a square function. So first let's just write the usual way. The square function, it takes a number and we want it to return the number square. Okay, now let's just test this. Square of 2, we get 4. Now let's just rearrange this. So let's just take this, and the first thing that we need to do is we need to bring it here. Let's just test this again. Square 3, still 9, and we don't want this. We remove this and replace it with lambda. And we don't want parenthesis. Now if you put a parenthesis, it will throw an error. We don't want a parenthesis, and we don't want return also. Now this wouldn't run because we haven't assigned it to anything. So let's just write this as square is equal to lambda. and let's just give 4. It still works. And let's just test this out. So let's just remove this and let's just map this to num list 2, and let's just typecast this to a list. Because we got square of it. Okay, it was 10, 20 and 30. List 2 was num list 2 was 10, 20 and 30. We got square of that. Okay, 100, 400 and 900, which means that it's properly working. Now that's all about map, filter and lambda expressions. Now let's move on to arguments and keyword arguments. Let's create a function as, let's say, adder. Define and to create a function adder which takes in arguments, let's say number 1 and number 2, and the output it returns, let's say, a sum. If you are providing 2 numbers, it should be a tuple. So num1 comma num2. Now let's just test adder, just to be sure that here I had named it as add rather than adder, so it is a different function. Okay, so it's not the same function. I'm recreating it. Adder 5 and 6, I get 11. Now this looks decent enough. What if I want to add 3 numbers? If I give 5, 6, 7, or let's say 1, it would throw an error because it only takes 2 positional arguments but 3 were given. Now how to overcome this? One way is you can actually create a num3 and set a default value of 0. Now if you only have 2 numbers, the other value will be 0 and you will get 11. And if you put 1, sorry, we need to put it here also, num3, you get 12. Now if I want to add 4 numbers, I need to put num4 0. I need to add it here also, num4, and this still works. If I put 2 here, I'll get 14. But what if I want to add 10 numbers or 7 numbers or 20 numbers? I cannot keep on giving like this. So this is where the arguments function comes, or the keyword or the argument gets used. The special function known as argument gets used. So basically here you want to accept arbitrary number of arguments without having to predefine a set of arguments. That is what you basically need. So what you do is you have to write define adder and you put a star and you put args, and what you return is sum of args. You can see that I didn't put args inside a tuple. Now that's because when we put a star, what Python reads is that whatever argument that follows, okay, the user can give as many as they want, and all that will be put or will be treated as a tuple inside the function. So now let's test this. Let's rename this as something like add a new. Okay, now add a new, let's say 1, 2, produce 3. Just produce 1 comma 2 comma 3, it will produce 6. I can give like 4 5 6 7 8 9, give 45, and that is the beauty of args. Now note that it is not this word that is important, but rather this star. If you replace this word with, let's say, num or anything for that matter, it would still work. But this star is what informs Python that it has to be treated as args. But we generally always write this as args because if someone else is reading our code, they need to realize that we are using args here. And that is why we generally follow the convention of putting star args. Okay. Now in the same manner, I need to take arbitrary amounts of input data. Here instead of that, what I need is student details. So let's write define student details, and these details are about students who are trying to join an entrance coaching center, where they need to write their name, their age, and their marks in physics, chemistry, mathematics, and biology. Now why mathematics and biology? They can either choose an engineering stream or a medical stream. Now if you are choosing for an engineering stream, you only need to give physics, chemistry and mathematics, whereas if you are choosing a medicine stream, you need to give physics, chemistry and biology. And there are some students who opt for both, so they need to give physics, chemistry, mathematics and biology. Okay, and let's return all this. Return all this. Now since we need to give arbitrary amount, why can't we use args? Let's look at that. Let's copy this, and instead of this, let's give it as args. Okay, and let's return args. Okay, let's rename this as 1. Okay, so student details 1. I'm going to give, I'm going to give student details 1. I'm going to give the name, let's say Ajay, and let's say he's 16 years old and he got physics marks as 89, chemistry, as he is opting for engineering stream, so let's just give physics, chemistry and maths. So chemistry as 81 and maths as 92. Okay, you can see that I've got an output like this, but from this output it is not clear what 89 stands for, or what 81 or 92. So to which subject it belongs, it's not clear. It is only clear for someone who had actually created this function. So the args function has a drawback here. Now can we give it something like name is equal to Ajay, something like that? Name is equal to Ajay, age is equal to 16, I'll just run this. You can see that it will throw an error because you cannot actually assign it like this. If it is args, you cannot actually assign it like this. So what do you do? This is where keyword arguments come. Now before that, why can't we use this? Why can't we use this one? Let's just say if the student details, let's say name is equal to, let's give the same thing, Ajay, age is equal to 16, physics marks is equal to, I think, 89, chemistry is equal to 81, mathematics is equal to 92. Let's just put these, let's make these as default values. Okay, so Ajay 16, 89, 81, 92 and 0. Even here it is not clear to which subject it belongs. Moreover, there are several other issues. What if the student writes, instead of capital name, he wrote like NAME? It would throw an error. Or let's say instead of physics or mathematics, he wrote maths. Still an error. Or sometimes student may write PHYCHEM, chem, like this also. Okay, it means that the edge cases, there are a lot of edge cases and it would throw error every time. Instead of that, what we are going to do is we are going to give here keyword argument like this. Let's say double star keyword arguments and return keyword arguments. Now let's write student details 1. Right, student details 1, and right, name is equal to Ajay, age is equal to 16, physics is equal to 89, chemistry is equal to 81, maths is equal to 92. You can see that you got an output. Now some other student wrote like this, student details 1, name is equal to Veena, age is equal to 16, physics is equal to 94, chemistry is equal to 91, biology is equal to 95. It would still produce an output. And this is the beauty of keyword arguments. It would take a variable name along with the value that you give, and the output is in the form of a dictionary with a key value pair. So in such situations, it is better to use keyword arguments. And with that, we'll finish today's session. We'll meet next time. Thank you.